Hi all. I hope you can see and hear me. Welcome to the ELLEGO Airport Solutions webinar. My name is Mina Kreili and I'm hosting this webinar together with ELLEGO. I hope we are all online. It's 11 o'clock in Madrid, so we start. This is basically a first part of the two-part webinar series where we are taking closer look at the ELLEGO's new LED technology solution, AGL 3.0. And this first webinar is about LED native AGL currents, and it has more of an engineering edge, whereas the second part will be more sustainability perspective. Before we start, I want to go over a few things. If you haven't already, please click to ELLEGO LinkedIn and follow us. That way you will receive all updates of upcoming webinars and also product updates and any information. Next, we have reserved some times for a Q&A after the presentation. So if you have any questions or comments during the presentation, please write them to the comment and we will go them through at the end. Then the last one, this is the first ever ELLEGO webinar, and we would love to have your opinion and feedback. So let us know during the webinar or after it, what are you thinking about the arrangements? Does this LinkedIn Live work for you? Or would you prefer to have like the future sessions in Zoom or any other platform? Just let us know. This webinar will be recorded, and you will find the recording from ELLEGO LinkedIn and also later on from ELLEGO website, www.ellego.fi. We have now reserved about 40 minutes for the presentation and 15 to 20 minutes for questions and comments afterwards. So I think you have heard enough from me at this point. So I'm going to turn it over to our speaker, Otto Vainio. Let me pull Otto in. Hi, Otto. How are you?
Oh, thanks. It's perfect, Mina.
I can hear you. I think you're ready for the presentation.
Yes.
So I will pull this presentation in. Just give me a second. There it is. So we are ready. I will let you to speak about AGL circuits with native LED currents. Go ahead, Otto.
Oh, thank you, Mina. So today we will be concentrating on the engineering side of what we call AGL 3.0. And as Mina mentioned, it's really AGL circuits, the all familiar series circuits, AGL series circuits with native LED currents. It will be explained later what we mean with native LED currents and why they are actually very important for power savings and other benefits as well from the traditional well-known series circuits. First, a few. Now it actually Minna, I think you need to change the slide since it's open by you. Thank you, Minna. First, a few words about ELLEGO PowerTech. As the name ELLEGO may not be that familiar for you yet, ELLEGO is a Finnish power electronics company founded in 1979, so more than 40 years of power electronics business or within power electronics business, located in Halikko, which is in southwest Finland, roughly 130 kilometers west from Helsinki. A medium-sized company between 40 and 30 employees. 35 is probably the current number. And within this power electronics business, CCRs have been a big part of ELLEGO's business historically. So ELLEGO does have knowledge or history of manufacturing CCRs for more than 30 years. Then next, please. Yes. So the ELLEGO AGL 3.0 solution we'd like to think of that as a minimal approach to LED-based AGL in series circuits. So it will be later more clear what we mean this minimal, but it's really the key design concept, not just the current, but also all the elements, the technology, all the parts within a series circuit. Quite like trying to replicate more or less the simplicity of the halogen. Then we can go to the next, please. As said, it's not just the current. We'd like to also minimize the use of materials, especially in today's environment where the scarcity of just bare material starts to be a major player. We'd like to keep what is working and replace only what is necessary. So not to introduce new parts, uh, new materials into the field if not necessary. If there's something that can be reused, we'd like to reuse it. In this, yes, please. The In our approach, at the minimal installation, the only things needed to replace from a shift from halogen to LED is just the CCR and a bulb. And by a bulb, we really mean an LED bulb, something that looks like an halogen bulb, but is working with an LED. With this minimum replacement, just the CCR and the bulbs, energy savings up to 95% can be achieved. This is possible with this patented ELLEGO power control innovation, which we will shortly introduce. And we'll also give some background to this bold claim of 95% energy savings later. Yes, please. The constant current series circuit, it's a current controlled method, a way to control the power through current, a well-known, a simple, robust technology to control the luminosity, for example, in AGL, the luminosity from the fixtures from a single point, a centrally controlled with the current, with the RMS value of the current, the luminosity from the fixtures can be directly controlled without any active parts within the circuit. So the only active player is the central controlling unit, and in AGL, this is the CCR within the substation. What we would need to do here, because there's a fundamental difference between how the halogen and the LED produce the light. Halogen requires a minimum amount of current in order to produce any light. The AGL currents have traditionally between 2.8 and 6.6 amps, whereas a halogen, a diode, LED diode, starts to produce light as soon as there's any current going through. So if we want to control an LED directly, we will really need to start from zero up to whatever the required current level is for the maximum required luminosity from the LED. And this is a bit of a challenge with a kilometers long AGL circuit, but we will show you in a few slides how it can be managed. The only key difference between AGL 3.0 and a traditional 6.6 ampere system is the current, the RMS value of the current going into the circuit. Yes, please. This all started a little over 5 years ago at ELLEGO with this idea that what if we would reduce, take away all the electronics within the circuit and just use the CCR to directly control the LED diode within a fixture. I joined ELLEGO shortly after the very first realization that this might actually be feasible. And we started with, this was actually the very first thing I started with in ELLEGO. We started a research project. First year and a half, even maybe 2 years, was more or less just research looking into the dynamics of an AGL circuit. It's in order to control all the variables, you need to do it on a computer. It needs to be simulated. So we built a computational model with enough detail of the insides of the CCR, with enough adjustable details of the cables. The cables play a big role in there, as do the transformers. So the accurate transformer models for different kinds of transformers need to be produced. And of course, the load, what happens in the secondary of an AGL. A series circuit is the, the same fact that it allows an accurate control from a single point in a long circuit. Is the counter side of that is that everything within the circuit affects the circuit, the entire circuit. So the whole circuit has to be understood in order to be able to simulate what will happen there in any given situation. So with these computational models, we spent thousands of hours of simulation time looking into various scenarios within an AGL circuit. So this, the next please. This led to a realization that even though the standard 50-60 Hz sinusoidal or phase angle thyristor type signals are very good for standard currents between 2.8 and 6.6 amps, nothing wrong with that. They work well. They have been working for tens of years, so we know that that works. But when we go to really low current, when we go below 1 amp, which is really needed in order to be able to adjust the luminosity from an LED, it benefits from actually stepping outside of this 50-60 hertz sinusoidal standard signal. So modifying the frequency slightly, modifying the waveform slightly, it increases the improves the power control, and it can also affect the light quality quite a bit. But the modifications have to be slight enough so that the 6.6 amp cables and transformers already installed within the field can be still used with this new technology. Then next, please. With all this knowledge from the AGL circuits, it became clear to us that a totally new type of a CCR would be needed. It's just the same kind of a CCR as is known from or any other AGL circuit, a central controlling unit for the power for the AGL circuit with a constant current control, but it does things slightly differently. So the signal is not exactly the same that comes from the more traditional CCRs. The fundamental key element here is that this ELLEGO CCR is capable of controlling the AGL currents. We quote this number of 50 milliamps, but that's not actually a technical limitation. We have run currents down to 14 milliamps in a 5 kilometer existing field installation circuit with stable current. But we quote this 50 milliamps as a low enough current to be able to, for all use cases, to cover the needs. Also, because the powers go down so much, a single CCR model is all that is needed. There's no need for power variance. A 3 kVA unit is capable of providing for all needs. We've chosen to keep the voltage below 1 kV, 1 kilowatt. So this is a low voltage. All 3.0 AGL circuits from ELLEGO are low voltage installations. Of course, an IGBT-based technology, a modern power supply, and therefore also no sharp voltage spikes, no leakage currents, less cable wear, less transformer wear. All these benefits sort of follow naturally from the low currents. Touchscreen user interface and the local PC connection for easier maintenance and uploading parameters, downloading the history of the unit, and basically just for any communication with the unit, PC connection is probably the preferable one. Of course, everything will work just as well from the touchscreen user interface as well. The first field installation was a little more than half a year ago here at our local airport in Turku. There will be a little bit more detail about that later as well. Then next, please. The other part. So CCR is needed for the power control. That's the key. That's the heart. That's where everything starts. But it needs to have a counter player at the field to produce the light. So therefore, we came out with this idea of replicating the halogen bulb with an LED bulb. So what we call the ELLEGO LED bulb, we've designed a handful of power variations which can cover all the AGL needs. So it's available in both PK30D and reflector type mechanics, closely matching the halogen mechanics. There are some minor differences in the details. So the applicability needs to be tested every time, but it's very close, and in most cases we have found no trouble fitting it into the picture. We think of this as bringing the efficiency of the LED and combining that with the simplicity of the halogen. So getting the good from both worlds and bringing the new into the old in a natural way. Because it's a passive components, there are very few electronic components within, and everything is passive within the bulb. The expected lifetime gets very high. From the laboratory measurements, what we get just from the normal decay of the light, uh, it's this very usual number quoted of more than $250,000 down to 70% of luminosity. That's a ridiculously large number. What the real world lifetime will be, we just don't have the statistics yet. We don't have any failures yet, that's to say. But we put every effort to make the bulb as durable as possible, which is easier because it's so small and there's so few components in there. We intend to cover all the use cases. So this is really a solution. This will be a solution for the whole airfield: approach, runway edge, runway center line, taxiway, of course, naturally, and the signs. And then we can go to the next. Again, yeah. So here's a quick look at the different power variants. It's more like voltage variants. All of them can produce a lot of light. Even the low intensity versions, the current versus voltage variation is more to adjust the current levels to a reasonable level, and a level that's not too high, not too low. And also going down with the voltage in the low intensity versions allows for more bulbs within a set. So the low intensity version, 3 volts version, we can cover up to 250 bulbs or fixtures if it's a single bulb fixture per AGL circuit. And then number of bulbs getting slightly higher and lower with higher voltage. 12 volt version, 70 bulbs per circuit, covering the more high intensity applications, approach, runway edge, threshold, stop bars, these kind of locations. And the same with reflector. On the next slide, we see a little less variance. We cover the MR16 and the MR11 compatibility in mechanical fitting. Here we don't actually need power variants as such. There's quite a lot of light, enough light for most applications. We haven't yet found a fixture where we would need more light. But as the development work is continuously going on, so these figures are slightly live. But these, what's shown in here today, is something that's already fixed and getting towards production. Then we can go to next slide. So the bulb, of course, it's not enough by itself. It needs a fixture around itself to be an operable AGL component. As a first step, we've taken this kind of a retrofit idea of using what's already working in the field and repairable and something that can be refurbished with an LED. But if we put an LED bulb into an existing halogen fixture, we try to match the luminous output of the halogen as well as we can with the LED, but it's not exactly the same. The luminous output from an LED is so much different from a halogen that it actually takes a little bit of effort to make it look like a halogen. I think we've done a pretty good work with that, but we'd like to, and we think that it's crucial to photometrically test each new picture type we encounter. Of course, this test only needs to be done once per picture type, and here are examples of two such verifications. One for an approach light with an LED bulb in it, and this is showing the current where it just matches the IKU requirements for a high intensity approach light. This is not the full capability of the bulb. This is just looking for the limit where it matches it. And we can see that the luminous output or the candle chart is very nice. It's more or less exactly matching that of the halogen. And on the right hand side, the same with the touchdown zone logs. Both more or less plug and play retrofits. Then we can go to the next slide. So here we start with real world examples of retrofit designs or retrofit installations we've done so far, reusing halogen fixture. This is a low intensity approach line, a local airport here, Turku Airport, quite close to where I'm at the moment. We replaced the 45-watt halogen bulbs with LED PK30D medium and intensity versions. On the figure on the left hand down corner, you can see the LED bulb already installed into this existing halogen fixture, and this was actually one of the installations where there was absolutely no retrofit kits or any mechanical changes needed in the bulb. It was just taking the halogen bulb out and putting a little bit of thermal paste to ensure the good thermal contact between the LED bulb and the body of the picture, and inserting the LED bulb into the picture, and Bob's your uncle. That's all we did with this first installation. It's been running for, what is it, 2.5 years now, since late 2019. We don't have a single failure in these two approach lines yet. So we don't have any statistics from them. Of course, it's just a few tens of lights, but still, we wouldn't expect any failures so far. Then if we go to next one, this is a slightly more complicated one in installation, or actually the installation, that's wrong to say. The installation was not complicated. The installation was actually exactly the same as a halogen refurbishment for the light would have been after years of use, accumulation of water or whatever in the picture. When the picture is cleaned and refurbished for the halogen, the same procedure, but we replaced, in this case, an inset light, we replaced the bulb support within the picture in order to improve the thermal contact. So that was a retrofit installation to be done once. The retrofit kit is, in this case, is designed and provided by ELLEGO, but for the fixture maintenance, or the person doing the fixture maintenance, it was the same as replacing and cleaning the halogen support in there. And this specific inset light has been in real life field use for pretty much exactly a year now. An LED 50mm reflector replacing a 48-watt halogen reflector, of course. And then go to the next solution. This is a taxiway edge retrofit installation. This could have been just replacing halogen with the LED without any retrofit kit, but in order to ensure the longevity of the LED bulb, we expect it to serve for years and years. It makes sense to make sure that the bulb is fitting very well into the picture and staying in place, and especially to guarantee the thermal contact. In this case, also a strain relief for the cable was installed with this improved bulb contact or bulb support. This specific light has been in field use since October last year, and in the next slide we can see, yes, this is the exact installation where it is in Turku Airfield. In this installation, a taxiway edge circuit with 58 taxiway edge fixtures and 9 signs with altogether 130 PK30D halogen bulbs with 45-watt nominal power were replaced with medium intensity LED PK30D LEDs, also of course 130 of them, with nominal power of 6 watts. So existing fixes, existing signs, existing secondary transformers, and all the existing secondary cables used. So the only replacements were the bulb with the pulp support into the fixture, upgrading the fixture, and an ELLEGO CCR providing the power. Then if we go to the next one, there's a little bit of detail from inside of the sign. So here you can see from the middle of the retrofit process, these 9 signs held altogether 72 bulbs in them. You can see the most right-hand side fixture in there. The bulb holder within the fixture has been replaced with an aluminum plate in this case to improve the thermal compliancy. Strictly not necessary, but in this case, actually, it was required by the mechanical fitting that was in the sign originally. So this is more of a case by case what needs to be done, whether it's just a simple taking out the halogen and putting the LED in, or whether there has to be a retrofit kit, or whether it just makes sense to slightly modify the contact point between the fixture and the bulb. And what it looks like from the electrical side, this same taxiway edge circuit, the approximate knowledge I have from that is roughly 4 kilometers of primary cabling and quite a bit of secondary cabling as well, especially because it goes to the sign. Some of the fixtures, of course, don't have that much of secondary cabling because they sit on top of the cans directly. Here we have a measurement from the midfield. So this is as far as practically possible from the CCR in the middle of the series circuit. The nominal power for this circuit. So when we did the retrofit installation, that will actually show up better in the next slide, actually. So the 1 amp is the current that's normally run in this circuit, and that's more or less matches the neighboring halogen circuits. I would say that the LED is slightly brighter than the halogens with their nominal power in this case, but I'm perhaps a little bit biased. It's 1 amp normally run, but we also tested it with lower currents just to check that everything works as it's supposed to be. The currents in this case were 500 milliamps. You can see the average curve in the on the graph there. 200 milliamps, 100 milliamps, and 30 milliamps. So these are measurements from the middle of the series circuit. The fluctuations, there's a little bit of fluctuations you can see on the lines, but it's in each case, it's the maximum fluctuation we got from these measurements was less than 1.2%. And this is not actually the latest control version of the software in the CCR either. So there's room for improvement, but we're quite happy with this one too. Nothing visible in this kind of fluctuations to the naked eye. Then if we go to the next one, let's look at what it comes down to in energy. So these are measurements, verified power savings and measurements from the input side of the CCR, from the supply network side of this taxiway edge installation with 130 bulbs. The halogen current that was used in this case was 6.4 amps, and the power consumption with that was measured to be a little over 9 kilowatts. With LED, the current matching this 6.4 amp luminous power or luminosity value was 1.0 amps. That's actually one of the nominal currents of the LED medium intensity or low intensity LED bulbs. Power consumption from the supply network into the CCR was 760 watts. So that's a power drop of a little over 91%. So that would more than 90% savings in this single step use case with a single on-off circuit. So it's more or less full power all the time. We also checked the current with the 10% usage level. it would have been 4.1 amps for the halogen, and the input power was so again this is a measured value, 2.68, slightly less than 2.7 kilowatts. But with the LED run at 10% luminosity, because the LED is a linear device, if 100% usage is 1 amp, 10% is 100 milliamps. And with 100 milliamps, the power consumption from the supply network was measured to be 110 watts. Out of that 110 watts, 75 watts went into this 130 bulb circuit with 9 signs, 58 taxiway edge fixtures. And the rest, roughly 40 watts, is internal losses within the CCR. And that's a power saving of 96%. Then, of course, for any given circuit, it depends on the usage cases. It depends on the actual required power and the levels, what current levels are used. In this case, and this is by far not an extreme case, but even in this case, there's a lot of power losses within the cables with these standards from 2.8 till 6.6 amp current. Everybody knows it's current squared, the power losses within a resistive device as the cabling. So if we go down with the current, we not only save, we bring it down to the natural LED levels where we don't need control electronics in the fixtures. The reliability goes up, the power losses within the fixtures come down, and then come in the cable losses. The cable losses are reduced to a very, very small amount if we go to native LED currents within the entire series circuit. Then if we go to the next slide, please. Today's talk has been introducing mainly retrofit installations where we have kept the existing fixtures, and we think that that is a good idea. In the modern world, we think that everything that can still be used should be used, if possible, in its original application, if not recycled to be used somewhere else, but reused as much as possible in its original application. So therefore, we came approaching this whole upgrade with this retrofit idea. But AGL 3.0, the native LED currents within a series circuit AGL current is not limited to retrofit installations. And of course, even the retrofit installation, at some point sooner or later, there will be a need for replacement fixtures. So new fixtures will need to be introduced at one point or the other. And the first third-party new design fixtures specifically designed for LED are already being developed and actually pretty much ready, if I'm not mistaken. The AGL 3.0 and native series circuit currents is also not limited to the LED. The LED is just, in our opinion, the first, and we think it's a very good solution for any AGL circuit. But the AGL 3.0 native LED current technology is not limited to the LED. It can be a native LED fixture, which there are already a lot installed. Can also be modified for ELLEGO CCR compatibility. And first steps toward these kind of modifications have already been taken as well. It's depending on the fixture, it can be a very straightforward work as well. So this, we think that the AGL 3.0, which really means bringing native LED chip current, LED diode current into the entire AGL circuit, is a solution with a broad impact. It can be used with many different technologies. And therefore, really from the ELLEGO's point of view, we'd like to welcome everybody to join AGL 3.0. Any comments, any contacts, there's our R&D head, Terho Kaikoranta, will be more than happy to answer any questions. Then I think, Minna, the next one we are getting to this reminder of the next webinar in 2 weeks. Would you like to take over, Minna?
Yeah, thank you, Otto. So I think we covered this more technical part. Now, and the next webinar will be in 2 weeks. It's about sustainability, circular economy, total cost of operations, a little bit different perspective. But I think we could take some questions. I have one, and I will pull Terho with us here to the studio. Hi, Terho.
Hello, everyone.
Hi. Actually, we have one question. If I will put it there to show, just a second. So if I would like to make a pilot installation with ELLEGO AGL 3.0, how I should start and who to contact with?
Okay, so best approach is to take contact to Ellicon, for example, to my email, and then we can start evaluating how to go forward. But basically, it means that we need to study a bit on your actual case, so what kind of circuitry you have in mind, what kind of airport you have, what kind of equipment you would need. But we are more than happy to study this and evaluate that together to you and then find the right kind of piloting case. So we are happy to receive contacts, inquiries, and study how to go forward with you.
All right, and I think that if somebody is interested, they can be in touch with you or Otto.
Yes.
Correct. Thank you, Roger. I also have a question actually, and I received one question by private mail. I don't know. There seems to be some little issues with commenting. You mentioned that ELLEGO is open for new development for HEL 3.0. So now, if there is someone thinking of creating HEL 3.0 like product, what would be the process, or who they should contact with in ELLEGO?
That's pretty much the same kind of approach. So if you are, for example, a fixture manufacturer, you could contact us in Ellico and we can then discuss that what kind of fixture you have in mind. Is it the existing one or is it the new one? And then we can search the right way to go forward. But basically, we would evaluate how this would be implemented in your points of interest.
All right. Thank you, Terho. And actually, the third one, which I cannot get on the screen, it's a little bit more specific one. Is there a rack installation possibility with ELLEGO CCR? I think this goes to Otto probably.
Not yet is the answer. We've so far the local demand, and because it's a new design from the scratch, it was easier for us to work with the single cabinet design mechanically and for the test installations and to work in the laboratory. But there's nothing stopping from changing that into a rack mounted device. For example, a standard 19-inch rack installation. There will be some work to do it. It's not a trivial work, but it's straightforward. It's something that we can, if there is the need and will, it can be done.
All right. Thank you, Otto. If there are still some questions, feel free to post them. Terho, I cannot. There is some extra noise coming from somewhere, but anyway, thank you for participating this webinar. And as I told earlier, welcome to the next part in 2 weeks. And thank you, Otto, for giving us the presentation. And in the next webinar, our speaker will be Terho Kaikuranta. Terho is here in the studio, so he is the head of R&D, and I actually forgot to introduce Otto earlier. So Otto is senior technologist in ELLEGO. Both Otto and Terho have been in AGL 3.0 development team since the project got started over 5 years ago. So basically the next webinar will be about sustainable benefits of low AGL currents, and there we will drill down into this total cost of operation and impact on circular economy and this kind of topic, a little bit different perspective. The registration will be opening this week. And as I mentioned earlier, this webinar was recorded, the next as well, and these records will be available from ELLEGO LinkedIn and later on in the website, so you will find it from there. So I hope to see you all next week in Dubai Airport Show. ELLEGO team will be there as well, visiting. So if you have any questions for Otto or you would like to discuss about AGL 3.0 more closer, just drop him a message in LinkedIn, and he's happy to catch up with you. Right, Otto?
Yes, sure. Any comments, any questions, all communication, warmly welcome.
All right. I think we have covered everything today. So I wish you all a lovely day. Thanks for attending and see you next time. Bye-bye.
Yep.